Good morning, kids. Sorry I am out today, but just because I'm out doesn't mean we can't go over the last few pages of this work that we had worked on yesterday with your card sorting. You guys all did so amazing on the sorting of the cards. It was not the easiest. It was not the most straightforward, and you guys persevered and worked hard and figured it out, and I couldn't be prouder. So we're going to look this first, number one on the questions you were supposed to answer. Number one says, state the value of G50 and describe how you use the graph and table to find and verify your answer. So G50, this is the G equation, and I know that because G of X. Here we have G of 50. You should have learned about function notation way back in Algebra 1A. G of 50, you can see it looks like G of X, except for instead of 50, there is an X. So just like you might think, whenever it says 50, or wherever it says X, we're going to put a 50 if we were to work this problem out algebraically, which I'm going to do really quick. So G of 50 will equal -1 over 25 times 50 plus 12. Well, -1 over 25 plus 50 is -2 plus 12, and that is 10. So G of 50 is 10. I can find that out in several other ways as well. I can look at this table that was included when you guys did the card sorting. These are the answers that should have gone together. So G equation 2 here, and then when we plug in 50 for X, 10 should be our answer in the Y domain. Now, G of X and Y are the same thing. They're interchangeable, except for we can't use Y for all 6 of these different equations because we would get confused. So G is just a label. So when X is 50, Y is 10, which is what we also got algebraically. If you look on our table, or our graph of values here, when G is 50, it's going to be right in between 0 and 100. So we go up to see where we intersect our graph, and it was right there directly in between 8 and 12, which is 10. So I would say here on this line, these lines where you're supposed to describe what you did, you can find it algebraically using the equation that we just talked about. You can find it graphically by finding the X value on the X-axis and then following it up to see where it intersects your graph. So I'm going to write graphically intersections. How about that? And you can use your own words to describe what that does. Or we can do it with a table. We can find that value with a table by locating X and then getting Y from that. So locating when X is 50 and getting Y from that. Those, if you could put those ideas into your own words, that's what I would put there. Let's look at, oh, that all moved. Okay. I hope you've got this written down. If not, hit pause, because when I move this part, the whole thing is going to move. Holy cow. All right, so now we're going to do f of x equals 6. Well, that is the same as saying y equals 6. And describe how you use the graph and table to verify your answer. So what I want to know is what x equals when y is 6 in the f equation, which is this one right here, the f equation, f of x. You've got 1.5 times 2 to the x power. So let's do this. Let's figure this out algebraically. We've got 6 equals 1.5 times 2 to the x power. 1.5 is multiplied by 2 to the x, so I'm going to divide both sides times by 1.5. So we've got That'll give us 4 equals 2 to the x power. So I want to know what power I take 2 to get 4. Well, that's 2 squared is 4. That means x equals 2. So just like we did above with g of 50, we will say that on the f, this is really funky how this moves around. I apologize so much. On the f function, I can look at my table of values and see that when y is 6, x is 2. So on g, we've had x is 50, y is 10. For f, when y is 6, x is 2. It works both directions. Same thing with the graph. We need to know where y is 6. So that's going to be halfway between 0 and 12, which is right here, which just so happens to also be halfway between 0 and 4. So when y is 6, x is 2. So your answer for number 2 should be a lot similar to the answer for number 1, except you work backwards. This time we're given the y value and you need to find x. All right, number 3. When looking at the graph, oh, good Lord, it's all not moving. When looking at the graph table and equation for h of x, describe one reason why each representation is particularly useful. Describe the relationship between an equation and each one of the points on the graph. Okay, so here I want you to think about what the graph and the table and the equation tell us. The graph, if we just look at the graphs for f and g equations over here, the graphs give us the overall feel for how the relationship is changing between x and y. So graph will give you an overall vision for x, y movement. You can see how fast, what the rate is for the rate of change between x and y. You can see if it's got, in the case of this linear equation, if it's got a positive or a negative slope. You can see in the exponential equation if it increases by doubling or by halving. We can see if it's growth or decay. In this case, it's growth. The table of values, you can see specific instances to compare. And that's the table. If you needed to find the rate of change and you didn't remember how to do that with an equation, or it's not nearly as easy with a graph, you'd be able to multiply, divide, add, subtract between your y values to see what your rate of change is using a table. And then with the equation, you can test a specific instance. So this is equation. You can test specific points. To find out the exact numbers that you need to fill in your table or to fill in your graph. Okay. Number 4, describe the relationship between an equation and each one of the points on the graph. Well, the equation, I'm not going to write this down. I'm going to say it and you write it in your words. The equation gives you the data that you need to fill out the graph. The equation is where the points are plotted, and the graph shows you how to plot them, if that makes any sense. It's a visual representation of what the equation should look like. Okay? They're the same thing. The equation will give you the ability to plot more points in case you need to. Okay? One's visual and one's algebraic. That's the only difference between these two. Last but not least here, let's look at these whole group discussion questions. What I want you to do is we're going to connect what we think happens with each part of our equation and the table and the graph. So the first thing we're going to look at is something we talked about yesterday in this top problem. We've got the 6 here. Remember I told you 6 is the same thing. Whatever number is outside of the parentheses is your y-intercept. So when x is 0, this is x, this is y. When x is 0, y is 6. That's the number that's outside of your parentheses. It's also this number right here where your graph crosses the y-axis. So I would ask that you use now use a pen instead of a pencil, or another colored pen or pencil, so you can visually see the difference in color, because we're going to look at one other aspect of this equation, and that's the 1/2 inside the parentheses. That's going to be the rate of change of our graph that some of you may have noticed yesterday. So we're going to look at how the values change over time. X increases by 1 and increases by 1 and increases by 1. Y, we can subtract 3 to get from 6 to 3, but then when we go to 3 to 1.5, we subtract 1.5. So it's not a plus minus, and we already know that because it's an exponential function, right? So 6 divided by 3 is 2. So we divide by 2. 3 divided by 1.5 is divided by 2. And again, we divide by 2. Remember yesterday I told you that dividing by 2 is the same as multiplying by 1/2. So this 1/2 is what we multiply by to get our rate of change. On the graph, we can see this. We go from 6 to 3, that's times 1/2. From 3 to 1.5, that's times 1/2. From 1.5 to 3/4, that's times 1/2. So each time this hops from one point on our table to another, that rate of change is 1/2. And you can look at and kind of visualize that each time this bump changes, it's half as big as the one before it. And that's what we're really looking for. So that's the exponential version. Let's look at the, at the linear version. We know that our y-intercept is b, or 12. So when x is 0, y is 12 right here. That's also this point. Okay? Sorry, my dog is going to bark in the background. Your slope is -1/25. So that means when we go from one point to the next, and the y value, we're going to minus 0.04. And the same thing here, minus 0.04, which, just for completion's sake, is the same thing as -1/25. So that means that every time we have a new value on our graph, we move down by -0.04. So like it says on our graph, on our table here, when we get to 50, which is going to be right here, we've gone down 2 places. Okay, so we can relate the table, the graph, and the equation in every possible way. So I want you to pause here and go to the back page. Try these last 2 on your own, and then we'll meet back and put them together. All right, so which chart could represent the function f of x equals -2x plus 6? Well, we know that the 6 is your y-intercept because it's y equals mx plus b. So when x is 0, y has to be 6. So when number 1 matches, number 2, not a match. Number 3, not a match. Number 2, not a match. Number 4, maybe a match. Now let's look, the slope's -2. That means that each time the y position moves, we should go down 2. So when x is 2, let's plug it into our equation. Y equals -2 times 2 plus 6. Well, that is -4 plus 6, or 2. So when x is 2, y should also be 2. So 1 is not the answer, but number 4 definitely is. When x is 2, y is 2. So number 4 is it. Question number 2. The graph of y equals f of x is shown below. It's a funky graph. Which point can be used to find f of 2? Well, if we have f of x equals y, that means we should have f of 2. That should be where x equals 2, or point A. Okay? So when the x is 2, that means it's got to be x is 2 on our graph. All right. The reflection. When connecting a function rule with a table and graph, it is important too. I expect you to make some very studious comments and relate what we've been doing to what we've written down. And you're going to type those in to your computer here in just a second. Have an amazing day. Do the Desmos. Email me if you have questions. Be fantastic. The dog says hi. Bye-bye.